Hi! Freight transport forms the backbone of the today global economy, enabling business to operate across borders and meet the growing demand of the customer. However, with increasing expectation of the customers, government, and also investors, companies are now facing the challenge of not only optimizing their supply chain, but also minimizing their environmental impact. Forward-thinking organizations recognize that controlling greenhouse gas emissions is no longer just about the compliance. It's just a strategic business decision that drives efficiency, cost saving, and long-term competitiveness. Historically, comparing emissions across the different transport modes has been a daunting challenge, with numerous methodologies leading. The GLEC framework comes in, providing a globally recognized, standardized approach to emission calculation, ensuring transparency, consistency, and comparability across all logistic operations. By adopting the GLEC framework, companies can transfer their emission into the data actionable insights. Whether it is selecting more fuel-efficient transport modes, optimizing routes, or choosing the sustainable carriers, this framework empowers business to make informed decisions that enhance efficiency while reducing costs and environmental impact. Additionally, it provides a competitive advantage by helping companies with a smaller carbon footprints stand out with a crowded market. As the only globally recognized standard for a logistics sector, the GLEC framework also aligns with the ISO 14083, offering a comprehensive methodology for quantifying and reporting emissions through the transport chain. Whenever you are just starting with your sustainability journey or looking for a redefine your carbon accounting practices, this framework is an essential tool for meeting both regulatory requirements and stakeholder expectations. Today, I will provide you an actionable insights and technology guidance to understand the GLEC framework as a standardized methodology for quantifying and allocating greenhouse gases. Then we will focus on the two methodologies of the allocation, well-to-wheel and tank-to-wheel, to gain clarity of the key differences between these two approaches, and why understanding both of them is critical for accurate and actionable emission reporting. And finally, we will move on to the practical example. I will demonstrate you how to apply the GLEC framework step by step. So we will calculate emission for a refrigerated truck for a 620-mile round trip, breaking down every variable, from fuel consumption to emission intensity to the ton mile. By the end of this material, we will have a clear understanding of how to leverage a GLEC framework and digital tools not only to meet regulatory demands, but also turn emission reporting into the competitive advantage.
Go Mobility Tech. From digital strategy through custom software automation analytics and IoT to competitive advantage. Technology that drives transport. Go Mobility Tech.
So firstly, let's dive into the current trends and challenges into the sustainable logistics. To set the stage, here is the staggering statistic. The transportation sector contributes approximately 21% of the global carbon dioxide emission, with the freight transport being a significant part of it. Road transport is the largest contributor, accounts for 48% of the transportation emission, while aviation emission continues to rise and air travel rebounds and takes 10%. And shipping contributes around 20% of the transportation emission. As companies push for a sustainability and regulatory frameworks tighten, the spotlight is firmly how to logistic and supply chain operation measure and reduce their emission. So new carbon dioxide regulation for heavy-duty vehicles are driving change. This regulation mandates regular reporting of a real carbon dioxide emission using the onboard monitoring system. This push aligned with a framework like a GLEC, which set the standard for a transparent and accurate emission accounting across the logistic chain. So, Now let's talk about the challenges. Firstly, is gathering reliable, high-quality data from the diverse sources like a telemetry system, transport management systems, and from the subcontractors. It is a monumental task for you. Each data point, to be a fuel usage, distance travelage, or a shipment weight, has to be accurate and standardized for a meaningful analysis. Moreover, many shipments involve multiple modes of the transport and overlap with their other freights, making emission allocating tricky. For instance, less than truckload shipping requires detailed load distribution to the fairly assigned carbon dioxide emission to each shipment. For more, frameworks like GLEC demand precision and transparency. Companies must not only comply, but also ensure that their data is consistent and comparable across the stakeholders in the supply chain. You also have to know that balancing sustainability goals with the cost efficiency remained a significant hurdle. So implementing advanced tracking system or upgrading fleets to the greener technology can be capitally expensive. And last but not least, sharing emission data is crucial for a collaboration and for a compliance. However, carriers worry about exposing too much information like fuel usage or load factors, which competitors could exploit to negotiate better rates. These challenges may seem daunting, but they also present opportunities. With the right tools and frameworks, companies can not only meet these challenges head-on but also turn them into the competitive advantages. Up next, we will explore how technology and innovation can help you bridge with these gaps and pave up way for a greener future. Let's talk about the GLEC framework, an essential tool for understanding and managing carbon emission in the logistics. The Global Logistic Emission Council is an acronym for a GLEC framework. It's a global recognized methodology designed to measure and report greenhouse gas emissions across logistic and supply chain operation. Its goal? To standardize emission accounting so that companies worldwide can compare, report, and ultimately reduce their carbon footprints. But why it's so important? Because without consistent approach, emission reporting can become fragmented, making it harder to identify areas for improvement or benchmark performance against industry standards. GLEC framework align with the established standards like ISO 14083, ensuring compatibility and credibility. This alignment not only reinforces its accuracy, but also helps business to meet regulatory requirements while contributing the global sustainability standards. So let's dive into the key components of the GLEC framework. This framework is comprehensive. It covers all major modes of the transport, including road freight, rail, air, sea, and also inland waterways. It ensured emission reporting is inclusive and reflecting the real-world logistic operation, regardless of the mode has been used. To start prepared for a greenhouse gas emission accounting using the GLEC framework, it is essential to understand how transport activities are broken down. Let's begin with the definition of the foundation of this calculation. GLEC defines the transport chain as a sequence of the elements that freight from their origin to their destination. Each part of this journey, whether it's being transported by the vehicles or transferred through the hub like a port or a warehouse, is referred as a transport chain element, or an acronym for a TCE for a short. So GLEC simplifies things by using it like a vehicle to represent all modes of transport: trucks, ships, planes, or even the trains. It is an umbrella term that helps us to group different operations under the one system. When we identify transport chain, we could try to calculate its emission. But we need data. Accurate reporting under the GLEC framework hinge on the three critical data types. It is a fuel consumption, distance travel, and shipment load. So implementing the GLEC frameworks comes with its own set of the challenges. But each of these challenges also present the opportunity to optimize and improve its logistic operation. Let's explore some of the key hurdles and some solutions to overcome them. One of the biggest challenges in implementing of the GLEC framework is data accessibility. Collecting accurate real-time data from primary sources like TMS, transport management system, telematic platforms, or connected vehicles can be daunting. And what we can get from this system? For example, TMS data can provide valuable information on the shipment load, or from the loading or unloading times, or from the distance traveled. However, access for this data is often limited by the system compatibility or the involvement of the subcontractors who may not share their data. We can also get information from the telematics and connected vehicles. These tools are ideal for tracking fuel consumption and load weight, but not all fleets are equipped with them. And integrating this data into the GLEC reporting can be technologically complex. Following by that, we have to focus on understanding the type and quality of this data. You can ask why. Because the accuracy and reliability of this result depend directly on it. The GLEC frameworks break data into the 4 categories: primary, secondary, modeled, and default data. Let's start with the primary data. These are directly sourced from the transport operations, such as actual fuel consumption. Considered as a gold standard, primary data is collected through the direct measurement, including the telematic data or reading from the energy consumption meters. These are essential for calculating Scope 1 greenhouse gas emissions, and they are key data for transport service buyers should gather for a Scope 3 emissions reporting. The second one is, of course, the secondary data. They are based on the previous collected informations, such as the reports from the transport services providers. Secondary data consists of the aggregated information that they are not directly measured, but they are derived from the other sources, like a supplier's report. Although they are not accurate as a primary data, but it can be still provide a valuable insight when direct measurement they are not available. The third are the model data. This data they are just derived from the calculation just using tools and the algorithms. An example would be estimating the energy consumption based on the factors like a shipment size, the route length, or a vehicle type. The quality of the model data largely depends on the accuracy and of the input data and the assumptions used for the calculation. Finally, default data serve the last resort. It utilizes industry average values to estimate emission where no other data are available. While less precise, default data can serve as a useful starting point to identify high emission areas and priorities further data collection effort. Depending on the type of the transport, the availability of the emission data can vary significantly. When you are managing your own fleet or vehicles, you can rely on the primary data as the actual fleet consumption from the invoices reading from the telemetry system, which allows you the highly accurate emission tracking and reporting in accordance with the Scope 1 requirements. However, the situation is different where you are using external transport service providers, such as logistic companies, handling distribution centers, and the transshipment hubs. In such cases, we often have to rely on the secondary data, which also includes reporting provided by the contractors and may vary in accuracy depending on the data collection methodology. An even greater challenge arises in the air transport, where emissions are often calculated based on the model data, taking into account factors such as cargo weight, route length, or aircraft type. Similarly, in inland shipping, instead of the precise measurement data, we use an average fuel consumption values for a specific type of the vessels. In cases where detailed data are not available, we must rely on the default data, which is based on the industry-wide emission benchmarks and can serve as a starting point for a future optimization or for the carbon footprints. By aligning your data collection precisely with a GLEC framework, you can ensure that calculations they are accurate and actionable for possibilities, building the confidence in your emission reporting and reduction strategies. So now we have a data. We can start to calculate emission. To break down into the step-by-step emission calculation process, we will start by defining two key different terms that form the foundation emission reporting in the logistics, like a well-to-wheel and tank-to-wheel. There are key differences because well-to-wheel emission accounts for a carbon dioxide generated during the extraction, processing and transportation of the fuel before they reach the vehicles. This often overlooked factor is crucial in emission accounting. Addressing well-to-tank emission allows companies to gain a more comprehensive understanding of their environmental footprint and align with the broader sustainability goals. What is interesting? On average, the extraction and production of a diesel emit approximately 4.67 pounds carbon dioxide equivalent per gallon. For every 26.4 gallons of a diesel, this amount to the 123 pounds of a carbon dioxide equivalent released even before the fuel reached the vehicle tank. This highlights that the substantial share of a logistic company emission occur long before the fuel is burned, reinforcing the importance of including well-to-tank emission in the sustainability reporting and reduction strategies. Then is a tank-to-wheel emission, which represents carbon dioxide generated during the vehicle operation. Essentially, that's what comes from the exhaust pipe. This component is easier to measure, particularly when the fuel consumption is available. So burning 26.4 gallons of a diesel result in approximately 590 pounds of the carbon dioxide in the tank-to-wheel emission. And time to summarize. So we have to well-to-wheel. This emission encompasses the entire fuel life cycle, including production, processing, distribution, and the combustions. This approach provides a complete picture of the environmental impact of the logistic activities. So ultimately, burning 26.4 gallons of a diesel result in the total 730 pounds of the carbon dioxide, combining both well-to-tank and tank-to-wheel emission. So now you can ask, why don't we adopt the universal emission parameters for a given fuel? When calculating transportation emission as a well-to-tank parameters plays the crucial role for understanding the fuel environmental impact on a different type of the fuel. For example, in the case of the conventional diesel, we can add 15 to 20% of the additional carbon dioxide emission per gallon of a fuel, and we have generated tank-to-wheel emission alone. On the other hand, hydrogen produces zero emission once refueled. However, well-to-tank can vary significantly depending on the production method. If hydrogen is produced via the stream methane reforming from the natural gas without the carbon capture technology, well-to-tank emission can be very high and often extend as a 10 pound of the carbon dioxide equivalent per pound of the heat hydrogen. In contrast, when hydrogen is produced using the electrolysis powered by the renewable energy sources, well-to-tank emissions are close to zero, making it much more sustainable alternative. Despite the fact that the hydrogen fuel cell vehicles produce the zero tank-to-wheel emission, understanding the well-to-tank emission is crucial for assessing the overall environmental impact of the hydrogen as a fuel source. Similar situation applies to the electric vehicles, where well-to-tank emissions very significantly depend on the energy mix of the given country. In Norway, where the electricity grid is predominantly powered by the renewable energy sources, such as the hydropower, well-to-tank emissions are almost zero. This makes electric trucks an exceptionally sustainable option, with a minimal overall carbon footprint. On the other hand, in the United States, the energy mix is more diverse, with a significant portion of it still derived from the fossil fuels, such as the coal and natural gases. As a result, well-to-tank emission for electricity generated in the United States can range from the 660 to 1,100 pounds for a carbon dioxide for a megawatt hour, depending on the region and energy sources uses. This means that while electric vehicles in Norway can operate with a virtually no upstream emission, their counterparts in the US may still contribute significantly greenhouse gas emissions. This highlights the importance of the considering well-to-tank factors where we ascertain to the true environmental impact of the electric transportation. Incorporating well-to-tank emissions into the transport emission calculations allows companies to make more informed decisions about the fuel and energy sources, ensuring that the sustainability efforts and account for an entire fuel life cycle rather than the operation efficiency. So adapting well-to-well approach enables companies to better understand their total emission impact, and they take more effective measures to reduce it across the entire supply chain. Here is why this term matters. Tank-to-well is useful for measuring operation efficiency, but well-to-wheel give a holistic view, which is especially important for comparing different fuel sources and mode of the transport. GLEC frameworks use emission factors to calculate both tank-to-wheel and wheel-to-tank emission based on the data available. So, if the fuel consumption's data is available, it uses GLEC emission factors to directly convert into the carbon dioxide emission. But if the fuel data isn't available, the framework uses the well-to-wheel emission intensity factor, which are average tailored to the specific region and the fuel types. This ensures companies can still report calculation accurately even with limited data. So now, let's move on to the allocation method. The GLEC framework provides a clear guidance on how to distribute emission across the shipment depending on the type of the logistic. In full truckload logistic, the entire vehicle is dedicated to the shipment. Here is the total emissions for a journey are attributed that for a single shipment. Simple and straightforward. But when we have a less than truckload logistic, then we have involved multiple shipments sharing the same vehicles. In this case, emission must be distributed fairly based on each shipment contribution on the load. This typically involves factors like weight, volume, and the pallet space. Here is how it is worked for less than truckload. First, calculate the total emission for a journey based on the fuel consumption and the distance traveled. Next, distribute this emission for each shipment proportionally based on this share of the load. This method ensures fairness and accuracy, making the GLEC framework is a vital tool for a sustainable logistic reporting. Up next, we will explore how this calculation can help business identify opportunities for a carbon reduction and the optimizations. Once you've gathered the data, ensuring accuracy and the consistency across the logistic chain is crucial. Here is why. We have to standardize distance measurement. The GLEC framework emphasizes using the consistent method for calculating distances. For example, the shortest feasible distance should be used for emission allocating as a less than truck. GLEC framework emphasizes using the consistent method for calculating distances. For instance, the shortest feasible distance should be used for emission allocating less than truckload. This refers to the distance calculated on the road route that vehicle can take, considering any restriction that may exclude certain route due to the vehicle weight and height. This approach helps prevent systematic errors, especially when comparing results across different stages of the supply chain. On the other hand, when comparing flights, current conditions affecting on the actual air corridors are disregarded, and only the direct distance is taken into account. The takeaway here is simple. Accurate data is the backbone for a meaningful reporting. By leveraging the GLEC framework standard and fallback methods, companies can overcome data challenges and produce reliable, actionable insight. While data accessibility and accuracy may seem like a hurdles, there are also opportunities to strengthen your operations. By investing in a better data collection system and adopting standardized methods, you are not just comply with the frameworks. You are setting your business long-term success. Now we have covered the foundation of the GLEC framework and its implementation. So let's look how it works in the real-world scenario. We will explore a case study example and discuss the benefits of the GLEC-compliant tools can bring to all stakeholders in the logistic chain. So let's take the typical round-trip scenario to illustrate how emissions are calculated using the GLEC framework. A company transports goods via the refrigerated trucks over the distance of 310 miles. The trucks run on the diesel fuel and has a gross vehicle weight more than 34,000 pounds and complied with the newest emission standard. The truck's fuel consumption is 7.8 miles per gallon when fully loaded and improves by 50% when running empty. And trucks operate as a full truck load of the capacity. What we have to notice is that truck operates as a full truck load and the payload weighs as 22,000 pounds and it returns empty after the delivery. So let's start with identifying the key variables. The payload weight is 22,000 pounds. The truck consumes 7.8 miles per gallon when it's fully loaded and 15 per 6 mile when it's empty. Additionally, refrigeration increased fuel consumption by 15%. The truck operates on the full truck load capacity. Next, we calculate the truck fuel consumption for an entire trip. For the 310 miles carrying the load, the truck consumes 39 per 7 gallons of the fuel, which increased to the 45 per 7 gallons due to the refrigeration. On the return trip, running empty, it consumes just only 19 per 8 gallons. Adding this together, the total fuel consumption is 65 per 5 gallons. According to the GLEC framework, diesel trucks emit about 22.4 pounds of the carbon dioxide per gallon of the diesel during the tank-to-wheel operation. Additionally, well-to-tank factor for diesel production and distribution adds 5.43 pounds of the carbon dioxide per gallon, making the total well-to-wheel factor 27.83 pounds of the carbon dioxide per gallon. Using the emission factor, we calculate the total carbon dioxide emission. It is 65.5 gallons of the diesel multiplied for 27.83 pounds of the carbon dioxide per gallon, resulting in the approximately 1.823 pounds of the carbon dioxide for the entire trip. Finally, we determine the emission intensity. With a payload of 22,000 pounds, transported for 310 miles, the total distance covered to the goods is 3,410 ton-miles. Dividing the emission by the distance, we find the emission intensity of approximately half pounds of the carbon dioxide per mile. But how? Companies can reduce this emission by leveraging better planning tools. companies can minimize empty runs and optimize routes. For instance, using advanced transportation management systems like a TMS, companies can consolidate loads more effectively and avoid trucks running empty after deliveries. Selecting the right truck type for a payload site and the distance can also significantly reduce the fuel consumption. Additionally, transitioning to the electric or semi-electric trucks offer a transformative solution, cutting emissions drastically while aligning with the long-term sustainability goals. By adapting these strategies, business can make logistic operations more efficient and environmental friendly. By integrating these digital tools, the logistic industry can move beyond the compliance to create the truly optimized sustainable supply chain. The combination of the real-time data, automation, and the advanced analytics is not just the improving emission reporting. It's reshaping the way we are thinking about the logistics. In the next video, I will tell you something about the challenges with the data integration. So in this material, we've explored the challenges faced by the transportation companies in emission reporting, delve into the fundamental of the GLEC framework, and demonstrate how to calculate emission using the practical real-world example. This insight shows how data and technology can drive sustainability and operational efficiency in the logistics. Our team consists of the dedicated experts in the cloud solution and sustainability, who are ready to guide you through this journey. With our deep understanding of the emission reporting and advanced technology, we can help you transfer the ESG reporting more in the mere compliance requirement into the strategy advantage. By adopting our solution, you are not just optimizing your process, you are contributing to the cleaner, greener future. Let's join forces to create the future where the data-driven insight elevate your business while leaving the positive legacy for our planet. Let's join forces to create the future where the data-driven insight elevate your business while leaving the positive legacy for our planet. Together, we can build a more resilient, sustainable world where the logistics is not only efficient but also environmental and socially responsible. Let's shape the future of the logistics together.
Go Mobility Tech